Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, welcome back to school. Welcome to another school year and your 8th grade year of math. Not the way I was expecting it to start. Hopefully at some point we'll get back in the classroom this year. Those of you that might be viewing this in the year not 2020, this video is being made in 2020, just to provide a little context. I fully expect to use this for many years to come, so not as a replacement for being in class, just for you to have in case you missed class on any given day, or you just wanted to go back over and fill in some notes from what we were doing in class time. So I'm going to continue doing these videos. I'm not quite sure yet if we are going to be doing Zoom meetings for lessons or just to discuss what we learned after you've watched this. That would be my preference, but there are a few things that still need to get worked out. So let's just get into it, yeah, let's just go. Now, one thing I want to tell you, Chapter 1 tends to be review. And with this being the CPM math program where they love you doing group work, this is supposed to be a chapter where we review some of the concepts that we learned in previous chapters, where we sort of get a little preview of kind of the big ideas we're going to be learning in 8th grade. And it's meant for you to learn how to work or relearn after the summer how to work within your groups. So, you know, I mean, all of our lessons are based on group discussion and group work. If you're watching these videos, then you're probably working independently, probably at home, and so I'll sort of modify how the questions are asked and what our expectations are. So interpreting graphs, we're going to be doing a lot of graphing in 8th grade, where we're going to be working with situations where you've got two variables and one variable affects another variable. That's a really big idea of 8th grade math. And this particular lesson is meant to kind of show you that graphs, depending on what it is that we're working with, what it is we're graphing, graphs can tell a story just by looking at them. And so that's what we're going to kind of get into just a little bit today, and hopefully this won't be too long of a video, because I'm just going to be talking to you instead of us actually taking the time to do the work within our groups, which would take an entire class period. So let me go ahead and read this little introduction paragraph, and then we'll get into it. In the first section, you will focus on several challenges that will require you to use different problem-solving strategies. All of the problems are solvable with your current math skills, right? So that's what I was saying. It's kind of review. Some of them will be revisited later in the course so that you can apply algebraic tools to solve them more efficiently at that time. Each problem also introduces to you an important concept that you will study in this course. Okay, so part 1, getting to know you. You're sitting in a classroom with your group, and no, this isn't going to work for that. We're not going to be able to do this activity the way CPM wants us to do it. And so let me just kind of give you a bit of a run through here. What we're going to do is I'm going to provide you with a picture of a graph. And what I want you to do is think if you can come up with kind of a story for that graph. And I think in an ideal situation, you are watching this video, and then in the next couple of hours after this video is completed, we will be meeting in a Google Meet forum, and we can have volunteers share out their story. That's my hope. If it doesn't work out that way, it doesn't work out that way. And if you are not living in the year 2020, like maybe it's 2024, and you're hearing this and you're saying, huh, forget what I just said. Okay, so this is an example of a graph. In fact, I'm going to go ahead and fast forward a little bit. Here's an example of a graph. Here's an example of a graph. Here's an, no, that's an example of a graph. There's some graphs there. All of these have an X and a Y axis, right? And the X axis has meaning and the Y axis has meaning. And this right here is some suggestions of what you can do for your X and your Y axis, okay? Remember how last year when we were working in 7th grade math, how you would properly scale your x-axis and you'd properly scale your y-axis, and the x-axis numbers had some sort of a meaning. Like I remember there was a graphing activity we did where we had to look at the length of a bat and its wingspan. And we talked about like the association. Does the longer bat have the longer wingspan? Do you remember that activity from last year? So the x-axis was the length of the bat, and the y-axis represented the length of the wingspan. So you can have an infinite number of graphs with different scenarios for your axes, like time, distance, height, and their different measurements, water level, yards per second, how much money you earn, the number of people, and elevation. There are just so many different things that you can have on your axes, and you know, you could be like looking at the interaction between a runner, how far they go with how much time they're taking, or temperature change, how much does the temperature go up over time, or the same thing with money. Time is often something in your x-axis. So here's an example of one of those graphs, okay? And so you've got your x-axis and your y-axis, and you've got this squiggly kind of a line. It looks like it goes up, and then it goes back down, and then it goes up, and then it goes back down, and so on and so forth. This, when I first saw it, made me think of our swimming pool at my home, okay? In the wintertime, we can't swim, right? It's too cold. But in springtime, the water starts to heat up just a little bit with the outside temperature. But then once the sun really starts blazing on our solar panels, then heat starts to crank up. And so if our y-axis represents the temperature of the pool water, almost all winter long, it's somewhere in the mid 50s, okay? And then in March, it starts to climb up into the 60s, but then kind of stays there until about, you know, late April, early May, when we start getting 80 and 90-degree days, and then the temperature will go up during the day when the sun is beating on our rooftop with solar panels, and at nighttime it gets dark and we lose almost all of our temperature because it gets down into the 50, 60-degree range at nighttime again. And then the next day, the sun heats it up a little bit more, and then at nighttime it cools off. It's a little bit warmer than it was here and it was there because it spent all that day warming up. It didn't lose all of its temperature. Okay, and then the next day, and then the next day, and then I'm still experiencing it. It's July 18th, the day that I am recording this, and our pool in the morning is somewhere in the low to mid 80-degree range because all night long it was cooler. And then when it's been 100 degrees out for most of the afternoon, it gets up close to low 90s in the late afternoon. So I'm still experiencing this bit of a wave, although usually at some point it's going to start leveling it off, going down, coming back up. It never really gets beyond like 92 or 93 degrees. So here I have taken, if you can picture, let me just cover these guys up here. Cover these up. If you could picture just seeing this as a graph and deciding, huh, I think I can make a story out of this graph. That's what we're going to try to do today, okay? For my story, I thought, hey, let's take my pool scenario, which makes my x-axis be the number of days, all right? The number of days, time keeps on moving, and so, you know, day 0, I don't know, this could be after 10 days, and actually this would be each day, right? Day 1, day 2, day 3, and so on, because of that nighttime, daytime cycle. And then we are talking about the temperature of my pool. So I just put in those labels for our x and our y-axis, and then kind of tell the story. So remember, when you decide what your story is about, you need to identify what is the x-axis going to be and what is the y-axis going to be. So generally, whatever the x-axis is affects what the y-axis is. That's generally how this works. Like here, how warm was it? Well, it depended on which day we were talking about. As the days progressed through late spring into early summer, the water temperature started to go up. Okay? So there was a bit of a relationship there. The water temperature didn't cause the days to continue to move. It was each day as more heat is created from sunlight, the temperature would go up. So it's really the sunlight causing the temperature to go up, but also time is a factor in that. So I charted time on my x-axis. Then we want to tell a story and try and make it like 4 sentences, 3 or 4 sentences. It doesn't have to be an earth-shattering story. This is what I'd like for you to draw first. Here's your x-axis, here's your y-axis, okay? What is happening here, okay? I'm going to give you a tip here. Let's do this. Let's have this be our distance from home. Where this point right there would be your house. Okay? So this could be like 2 miles. This could be, oh no, I got to get that properly spaced, don't I? Does that look like it's pretty close? I'll move this down a little bit so that it looks like, does it line up with there? I'm not sure if it does. We'll pretend like those are spaced perfectly. Okay, so distance from home in miles. And let's once again have our x-axis be time in maybe hours. Okay. So if that's the case, tell a story. What is happening here? Is someone walking? Is someone riding their bike? Is someone taking the bus? What is happening? Because you're leaving your home, so you must be traveling, and time is continuing, right? It just keeps going on. And then what happens here? What could possibly be happening where time continues to move, but you are not getting any farther away from home, you are not getting any closer to your home. And then something happens here where you continue to go somewhere, and then at this point, how far away? Looks like you're almost 4 miles away from home. Then this arrow suggests that maybe you stay there for a while, and we're not going to worry about how you get home, okay? So go ahead. What is this scenario? Break it up into 1, 2, 3, 4 different parts. Those can be your 4 different sentences, and tell a story where you started home, but then you travel, and something happens here, you travel more, something happens here, okay? And this could be time in hours. I don't know that, you know, maybe this could be 30 minutes, maybe that could be the hour right there, or maybe this is 1 hour, 2 hours, 3 hours. It doesn't really matter how you label your hours, okay? But definitely include the time in it, okay? So this point right here is 1 hour. Then talk about what happened after 1 hour of riding your bike or 1 hour of walking or whatever you're doing, however you're traveling. And then if this is 1 hour, then that looks like it's a little bit more than 1 hour, right? So incorporate all of that into your 4-sentence paragraph. Okay, and now here's another one. Oh, by the way, sometimes what I like to do here is I like to say, go ahead and pause. I don't know if you can just tell, but I just paused. I'm going to pause again. Yeah, I just paused again. You can pause this video at any time that you want. So I'm going to move on to the next one, but if you want to just pause the video right now and draw this graph in and label everything, and is it working? Yes. And finish a paragraph before moving on to the next one, go ahead and do that. If you want to watch me describe the next one and watch the entire video through and then go through and watch the video again and then pause it later to write, or maybe you don't need to pause it later because you just know exactly what to do, you go ahead and use this video and use the pausing and back up and fast forward and do whatever you need to do so that it works on your schedule, that it works for you, okay? But I'm going to move on. If you want to pause right now, go ahead, and then when you unpause, I'll be right there for you. Okay, so what's happening in this one? What could we be doing if this was a situation where notice how we're not starting here. You know what this kind of makes me think of? This could be like your bank account. And by the way, just because I'm offering these suggestions like the previous one where distance from home and time and hours, you can make up anything you want, okay? I want it to make sense though. So if you're not sure what you're doing, go ahead and take my suggestions and work with them. Otherwise, You know, it's going to be a little bit later, probably in the year, where we revisit these a little bit. So this could be your bank account balance in dollars, and this could be number of months, right? So this could be 1 month, this could be another month, this could be another month. Maybe this is a 2-month period. Does that look like they're well spaced out? Hold on for a second. I want to make sure that this is scaled properly. Boom, boom, okay, and so on and so forth. Okay, so that could be number of months. That's supposed to say an H there, HS. Okay, so if this is your starting amount, you want to put in dollar amounts there, you could, right? We could say from here to here to here to here to here, and so on and so forth. All right, so what's happening here over time with your bank account? What happens here to your bank account? And why is this so much steeper than here, right? So if this was, are we good with having $500 in our account, and then $1,000, and then $1,500, and then 2,000, and then 2,500? Can that be good dollar amounts? You can make them anything you want. You can make yourself a millionaire. You have the freedom to do that with this lesson, okay? So what's happening from here to here? 2 months, you earned a certain amount of money, or at least you deposited a certain amount of money into your account. And then what happened in this 1 month period? I'm really interested to find out what happened here. And what on earth did you do with all your money? What happened? That's horrible. Unless, of course, you bought a really cool thing with that money, which I don't want to drop any hints, but who knows? And then so on and so forth. Maybe you go back to your spending. Maybe this could be a stock market kind of thing where the money you invested went up and then it went up and then there was a crash. Oh no, now you've lost all that money. If you would have just spent it here. No, you don't want to do that. Cash out there. But anyway, create your own kind of a story for that particular graph. Okay. Once again, pause so that you can draw this in. I'm going to delete everything here, just in case you want to be more creative with your own story, and go ahead and create something. And then when if we get a chance to during a Google Meet or a Zoom meeting, depending on what we do for our class, people can volunteer to share out their stories. Okay, so now please draw this right in here. You've got an x-axis, you've got a y-axis, and I'm going to cover this up for a second. Boom, boom, boom. Okay, there we go. And yeah, just draw that in first with A, B, C, and D. Notice how C and D, one is above the other, a vertical line, same with A and B. And notice that this horizontally, A and C match up and B and D match up. So this would be where you are supposed to be in your class with your group, and you've been talking about things that your group has in common with you, and maybe some things that are different. And then as a group, you're supposed to come up with some sort of a scenario where A and B and C and D can be different people within the group, okay? But we're not there. So this is my suggestion. I just decided, why don't you go ahead and copy this down. Let's pretend that the x-axis represents the age of the students in the group. And this doesn't, you're not going to be in a group with 15-year-olds. But it could be like some people were born in February, some people were born in April, or something along those lines. Just we'll go with that. And then the number of siblings that you have, like 1, 2, 3, 4. You don't necessarily have to label these with numbers. We don't really technically care what the ages are here or what the number of siblings are. We're just going to represent our x and our y axis with those situations. Okay, and so after you copy those down, then I want you to copy down these 3 questions. Go ahead and pause. I'm going to pause myself and go take a little break, but you copy down these questions, copy down these labels for your x and your y axis, and then answer those questions. Okay, and that will be the end of today's lesson. Okay, okay. Alrighty, I'm back. Hopefully you've got this completed and you're ready to check to see how your answers compare to mine. Okay, so the first question, remember the x-axis is the age of the students. And this question 1 has to do with the ages of the students. So which students in the group are older and how do you know? Which ones are younger? Okay, so remember on the graph, this point right here, which is called the origin, I'm going to go ahead and put a little arrow there. That's the origin, which represents 0, 0 on the graph. And so as you go farther to the right, these values increase. As you go up the y-axis, these values increase. Okay, so which ones are older and how do you know? Well, looks like C and D are older, correct? Because they are farther to the right on the x-axis. The farther you go to the right, the older the student is, right? And which one would be younger? Well, that would make A and B the younger ones. And for the same reason, they're farther to the left, closer to 0 on the x-axis. All right, now which students have more siblings? So if this point is 0, as you move up, the numbers get greater. So that would mean that students A and C would have more siblings because they're higher up on the y-axis, higher up on the graph, meaning B and D would have to have fewer siblings, right? So if this was 1, 2, 3, and 4, then these two would have 2 siblings and these two would have 4 siblings, and so on and so forth. We didn't bother with the numbering sequence. We didn't scale either axis. We don't really care what the numbers are. We just know that their relative positions tell us information. For instance, C is the oldest student with the most siblings, and B is the youngest student with the fewest siblings, based on their location in this graph. So, can you tell how many siblings each student has or how old the students are from the graph? And so the answer is no, you can't, not from this graph, because you have not scaled any of the axes. There are no numbers on these axes, so it's impossible to know their exact ages or their number of siblings. All right, so that does it for today's lesson. Once again, I'm thinking in the year 2020, we're going to talk about this a little bit later. If you are in the future and you're in your whatever. I'm going to start making something up ridiculous, but the video is getting late anyway. I probably shouldn't do that. Otherwise, if you ever have any questions about any of the content in our lessons as you're going through the lessons, please feel free to contact me. Send me an email and I will clarify anything for you. If you want to have a private Zoom kind of a chat session with me where we can talk about it, or a Google meeting where we can talk face-to-face, we can do that too, as long as I am not engaged with like some sort of a class activity with the other grade level with the 7th graders, okay? So yeah, just text me, no, I'm not giving you my phone number. Email me if you ever have any questions on any of this, and good luck with everything, and please make sure you do your homework. Homework, by the way, was listed on the front page. You're responsible for problems 4 through 7 and the M&Ms today. Please, any of those problems, copy the problems down if they're numerical problems. If they're big word problems, you just do the 5D process. Just pull out the essential information. If those of you that are new to 8th grade this year have never heard of 5D process, we'll get into it a little bit more, but it's just a matter of just pulling out the essential information. Don't copy down the entire paragraph of the word problem. Okay, please show your work to the best of your ability, and then we'll check the homework tomorrow. Okay, take care. Bye-bye.
Hey, Philly.